Let us begin by considering the general form of a line. Now the general form of a line is given by a times x plus b times y plus c equals to 0. So this is the general form of the line. Now we have also studied about the different forms of a line. That means given a line, we can represent it in the form of a point slope form, we can represent it in the intercept form. So there are several other ways of representing any given line. So today what we'll do, if we have any equation of a line given in its general form, that is ax plus by plus c equals to 0, we're going to transform into some of the most widely used form. For instance, so first what we'll do, we'll try to convert the given general form into the slope-intercept form of a line. Now we will have to remember that the slope-intercept form of a line is given by y equals to mx plus c. So here m, that is going to be the slope of the line, and c here represents the y-intercept of the line, the y-intercept. So what we'll do, we'll take the general form of the equation. So what we have here is ax plus by plus c equals to 0. So what we'll do, we're going to keep the second term as it is, but we will transpose the first and the third term to the right hand side. So we will get b times y, that is going to be equals to negative a times x added to minus c. Now let's divide each terms with b such that we get y equals to negative a over b times x minus c over b. Now what we can do, we can compare it with the slope-intercept form of the line. So when we compare it, so what we will get, on comparing we get the slope m, that is going to be equals to negative a over b, and then the y-intercept c, that is going to be given by negative c over b. So that means what we can have done here is, if we have the general equation of a line, or the general form of a line, ax plus by plus c equals to 0, our first task will be to determine the value of a, b and c. Once we have that value of a, b and c, we can use these two formulas to obtain the slope as well as the y-intercept of the line. For instance, let's say we have a line whose equation is given by 2 times x minus 3 times y equals to 5. So first what we'll do, we're going to rewrite it as 2 times x plus negative 3 times y plus negative 5 equals to 0. So on comparison, what we get here, we get a equals to 2, b equals to negative 3, and the c value comes out to be negative 5. So if we want to find out the slope m, then now the slope m comes out to be, so what we need negative of a over b. So what is a here? That's 2. So 2 divided by b. So b comes out to be negative 3. So we have m equals to positive 2 over 3. Then let's compute the y-intercept. Y-intercept is negative c over b. So we'll get negative. So c value, that's negative 5 divided by b, that's negative 3. This is going to give us negative 5 over 3, which means that a line 2x minus 3y equals to 5. So this can be expressed in the slope-intercept form as y equals to the slope 2 over 3 times x added to the y-intercept. So that's negative 5 over 3. So this is how we have expressed our given equation of the line, which was originally in the general form. We have expressed it in the slope-intercept form. Okay, fine. So let's now talk about the other form of transformation. So given the general form of the line, ax plus b times y plus c equals to 0. So we can convert this general form into the intercept form of a line. The intercept form of a line. So what is the intercept form? The intercept form simply states that an equation of a line can be represented as x over a added to y over b equals to 1. This is referred to as the intercept form of the line, where a represents the x-intercept. This is going to be the x-intercept of the line, or we can say the distance at which the line is going to intersect the x-axis from the origin, and b, it's going to be the y-intercept of the line. Okay. Now this is referred to as the intercept form of a line. So what we'll do, we're going to take our equation ax plus by plus c equals to 0, and we're going to convert it into the intercept form. So what we'll do, we'll keep the first two terms as it is, ax plus by, and then we transpose positive c to the right hand side to make it negative c. Let's divide throughout with negative c. So we get ax over negative c added to by over negative c, that is going to be equals to 1. And what we can furthermore, what we can do, take the first term and divide both the numerator and the denominator with a. So that's going to give us negative c over a, x divided by negative c over a. And in the second term, we're going to divide the numerator and the denominator with b, such that we get y over negative c over b. And this is going to be equals to 1. Now when we compare this with the normal form, so our x-intercept, so here we get the x-intercept, it comes out to be equals to negative c over a. And the y-intercept comes out as negative c over b. So we have now converted our given line ax plus by plus c, which equals to 0, which is initially in the general form, into the intercept form as x over negative c over a added to y over negative c over b. That will be equals to 1. Okay, so we can take the previous example. So earlier we took 2x minus 3y equals to 5. Let's take that same example. We took 2x minus 3y equals to 5. So what we'll do, we're going to first divide throughout with 5 to get 2x over 5 minus 3y over 5, that is going to be equals to 1. And then we're going to divide each the first term 2x over 5, the numerator and the denominator, with 2, such that we get x divided by 5 over 2 added to y divided by negative 5 over 3. This is going to be equals to 1. So here what we have done is we have successfully converted our given equation to the slope-intercept form, x over a plus y over b equals to 1, where we have considered a to be equals to 5 over 2 and b that came out to be equals to negative 5 over 3. Okay, then finally we talk about the normal form. That means we will need to convert, or to transform, the given general form of the line ax plus by plus c equals to 0 into its corresponding normal form. Now if recall what was the normal form of a line. The normal form of a line is simply defined as, so here let's say we have a line L, and then here OC is the perpendicular distance of the line L from the origin, and OC makes an angle of alpha with the positive direction of x-axis. Then the equation of this line is given by x times cosine of angle alpha plus y times sine of angle alpha equals to p. So this is referred to as the normal form of the line. So what we can do here, we're going to take the help of this equation and we'll try to transform the general form of the line ax plus by plus c equals to 0 into this equation. Okay, so let's do that. So here what we'll do, we'll start with the equation ax plus by plus c equals to 0. Okay, let's call it the equation number 1. Then the equation, second equation can be expressed as x times cosine of alpha plus y times sine of alpha minus p equals to 0. Okay, now what we'll do, we're going to solve this two equation. So here what we get here is, so we get a divided by cosine of angle alpha. Now that's going to be equals to b over sine of angle alpha, and that's going to be equals to c over negative p. Now what we'll do, we're going to take the two ratios at a time. So when we take a over cosine of angle alpha equals to c over negative p, so in that case we can get cosine of alpha, so that comes to be equals to negative p times a over c. And then if we take the ratio b over sine of angle alpha and equate it to c over negative p, then sine of alpha, that becomes equals to negative p times b over c. Okay, now what we'll do, we're going to square cosine function as well as the sine function and add them with each other, such that we get cosine squared a added cosine squared alpha added to sine squared alpha. So this becomes equals to p squared times a squared plus b squared divided by c squared. So that's going to be cosine squared alpha plus sine squared alpha. But we know that cosine squared alpha plus sine squared alpha, that is a standard value which equals to 1. The 1 is going to be equals to p squared over c squared multiplied to a squared plus b squared. Fine. Now from here well, we'll take out p squared. So p squared comes out to be equals to c squared over a squared plus b squared. Now p is the perpendicular distance of the line L from the origin, and since it's a distance is always positive, so what we'll do, we're going to take the positive square root on both sides. So p comes out to be equals to c times the square root of a squared plus b squared. Fine, so we have obtained the value of p. So let's do one thing. So let's substitute this, and this is going to help us obtain the value of cosine alpha as well as sine alpha. So cosine of alpha, so we got it as negative p times a over c. So cosine of alpha, that is going to be equals to negative. So here, if we replace p with c times square root of a over c, so we're going to get c over square root of a squared plus b squared, and we already have a over c. So here c and c is going to get factored out, and that's going to give us the value of cosine of alpha as negative a over the square root of a squared plus b squared. Similarly, we can find out sine of angle alpha. So sine of angle alpha, we consider it to be equal to negative pb over c, which means that sine of alpha is going to come out as negative b over square root of a squared plus b squared. So here what we have done, we have obtained a value of p, we have obtained a value of cosine alpha, we have obtained a value of sine alpha. So now finally let's come back to the general form of the line. So if we have ax plus by plus c equals to 0, this is the general form. This is the general form. Then we know that the normal form is equivalent to x times cosine of alpha plus y times sine of alpha equals to p. But what we have to do, we have to replace cosine alpha, sine alpha, and the p value. So in place of cosine alpha, we have negative a over the square root of a squared plus b squared. Then we have negative y times b divided by the square root of a squared plus b squared. And then this is going to be equals to p. So p came out to be equals to c over square root of, this is equals to c divided by square root of a squared plus b squared. So this is the normal form of the line ax plus by plus c equals to 0.